All right, it's 12 o'clock. We will go ahead and get started here. My name is Luke Pinkerton. I am the President and Chief Technology Officer of Helix Steel. Uh, just welcome many of you we've seen before on these webinars, and always great to have you. And there are a few new faces on here as well. As always, I have Peter available to answer any questions you have in the chat box. So if you look on the right-hand side of your screen and just open up the chat window, you can ask any question you have. As I am doing the presentation, Peter will answer the question, or if it's something that he feels we need to discuss as a group, he'll bring it up to me at the end. That's kind of how we'll do this. Today's topic for our Friday webinar is Better Ways to Build with Helix. And this is a presentation title that we've used in the past. This is updated a little bit to reflect some of the new International Code Council developments that we have that came out in June. So, really excited to kind of dive into that with you. One of the reasons we use this title for more or less our general webinar is it reflects our mission statement, and our mission statement is here. Helix leads the construction industry in providing better ways to build with concrete in a rewarding environment for our employees and community. So, in terms of what we do with the product and the way that we sell the product and work with our customers, that is really what we're trying to do. Everything that I've done kind of from a product development perspective, code advocacy perspective, etc., is really aimed at how can we do things better with concrete. So that's where that comes from. It's been in our mission statement for many, many years, and it really is what we try to strive towards as we approach the market, and just even every day within the company here. So a little bit about the company and the product. We have been in business for nearly 20 years. At this point, we have nearly 700 million square feet of installations of the concrete and flat work, and over 50,000 applications in vertical or foundation elements of buildings. So really a very deep experience we're very proud of, that ranges in use from maybe a residential homeowner all the way to companies like General Motors and Amazon AWS. These are some of our sort of marquee customers, but it kind of gives you an idea of the depth and the breadth of what the product is used for. I'll be talking a little bit more about applications, but just wanted to kind of give you a little bit of a background there. So today, what we're going to do is just kind of do a Helix introduction. I introduced myself a little bit. I am the president of the company. I am a structural engineer. I'm not a contractor. So this is going to be a little bit more of a contractor kind of, I'm approaching it. I've been in the business and I've been on plenty of construction sites over the last 20 years, but at the end of the day, I'm still an engineer. So just keep that in mind. We'll talk about, in particular, our ICC report today. And the reason we're going to be focusing on that is there were some significant developments in that report in June that we're very excited about. And, what we're getting from the market thus far is that those changes, those updates have made that report much easier to use. I will talk about applications, and then I'll invite you to take a next step on maybe looking at Helix in something that you've got going on. This is another one of our kind of marquee projects. This is the Seattle Ferris wheel, and Helix actually reinforces the foundations underneath this. So just demonstrates what we're able to do from both a structural and code approval perspective. So I talk about better ways to do things. everybody has different perspectives. Some people have pain, some people don't. You know, when we're selling things, what we're trying to do often is respond to an issue or a pain that somebody has. You know, we've seen a lot of pain in the market over the last few years. You know, I'd say the market's kind of coming back to a little bit more of a normal situation. But if we look sort of through the COVID era, and immediately post COVID, we had massive labor issue, you know, gaps, as seen in E&R there. And, you know, there was a period where people couldn't get building materials, or building material prices like lumber had skyrocketed, and, you know, just caused people to question the way they do things. And that can be kind of cyclical. It's not always there, but definitely there's always issues with these sorts of things from time to time. The other one that's kind of come up and become more and more important, even in the last 4 or 5 years, is the carbon neutrality topic. Everybody is trying to, well, not everybody, but more and more companies are trying to consider this in design. And, you know, a lot of companies are trying to sell their products around it. I'm not going to try to do that with Helix today. There are some benefits, but these are just things. There are some benefits to Helix in all these areas, but these are things that typically motivate people to look at alternative ways to do things, or better ways to do things. So what we have developed here at Helix is an alternative way to do things. It's called Helix 525. It is, at first glance, it appears very similar to a steel fiber. We call it micro rebar because it behaves differently from steel fiber. And I'll show you what that behavior looks like in a minute. But what it is it's like a little screw. So at the very simplest level, it behaves like a screw versus a nail. It locks itself into the concrete when you mix it in. It comes in boxes. You dump it into the concrete. I'll show you that in a minute. And then it reinforces the concrete very proactively because it's threaded into the concrete, like millions of little screws in there. And in order for that concrete to crack, those screws have to start to slip or untwist, and that takes a lot of energy. These things are about 1 inch long. They're about 0.5 millimeter in diameter, and they're twisted. There's 11,500 parts per pound. So you get a lot of distribution, a really, you know, dense distribution throughout the concrete when you use this, even at a lower dosage in terms of pounds per cubic yard applied. So when we put this into concrete, it does a couple of things. One of the things that it does do is it resists pullout from the concrete. So, you know, if you load the concrete up to a certain point, it'll eventually crack. And when it cracks, typically if you have, say, a straight piece of steel in it, the amount of load that can be carried is reduced significantly. And you can see what that looks like in the blue curve. The only thing that keeps the concrete from cracking more is the frictional bond between the concrete and that smooth fiber. When you twist it, we actually change that failure mechanism to an untwisting mode, which is what you're seeing here. You're seeing a piece of Helix being pulled through a piece of concrete. There's a little piece of tape on it that shows that untwisting as it comes through. That actually increases the amount of force that it takes to open that crack by a factor of 6 times. So when the University of Michigan was actually researching it, they were focusing on optimizing this property because that's what everybody looks at. If you're a structural engineer, you typically are looking for places in the concrete where there's tension and you're putting rebar there. That's your first charge. The second charge is you're going to assume the concrete cracks and that only then will the reinforcement take action. So if you take that theory and you own that theory or you accept that theory, Helix is very good. After the concrete cracks, it provides 6 times the load carrying capacity as a traditional straight steel fiber. Huge benefit. What the university didn't look at was the very basic principle of modulus of rupture. And modulus rupture is the amount of force that it takes to initially crack the concrete. That's something that structural engineers often ignore completely. And what we found actually, later is that we get a statistically significant increase in the modulus rupture as we increase the dosage of the Helix in the concrete. And the reason that it's able to do that is it's stiffer than the concrete and it doesn't slip because of that twisted shape. So load will always follow the stiffest path. The load finds the Helix. The Helix is able to carry the load without slipping. So it's able to carry load without those visible cracks forming, and it actually increases the amount of force that it takes to crack the concrete. Now, we can't double it with a cost-effective dosage. We're talking about more on the order of 10 to 20%, but that can move the needle, especially if you're going to design things in an elastic or essentially using that modulus rupture as your design criteria. If you look at a steel fiber or a synthetic fiber, you don't get the same effect. The steel fiber, you get some increase, but because the bond isn't as good, they don't have that continuous twist, you get slippage. So it takes a lot more to get the same behavior. And if you take a synthetic or a plastic, those products have an order of magnitude, 10 times less stiffness than the concrete itself. So by definition or by law of physics, they cannot increase that modulus rupture by, they can't because the material's not as stiff as the concrete itself. So what you'll see with a lot of those products is they'll quote performance in a beam test where they're measuring the performance after there's a crack that's formed that's roughly 3 millimeters wide or 1/8 of an inch. And at that point, they do provide quite a bit of capacity because they're able to stretch. And as soon as they stretch, they start to carry that load. They stretch because the stiffness is less than the concrete. So that's why you don't see increase in modulus rupture. In some tests, you even see decrease because at the stage where the concrete's uncracked, those fibers are seen by the concrete as almost like a void because they're not as stiff as the concrete themselves. So we can measure that performance using a standard ASTM C78 beam test, and we'll talk about how we use that in our ICC report. You can measure it in different size specimens. You can see one smaller specimen there and one very large specimen. Those are actually both ASTM C78 standardized beam tests. We can also measure performance in direct tension. We 10 years ago pioneered this method. I'm working with ASTM right now to further develop this and pursue it as a new standard at ASTM in a slightly different, a little bit easier to use form. When we do this test, we actually are looking at that post-crack behavior again. And what we find is the more Helix we put in there, the more resistance we get once that crack is formed. So all this science is certainly kind of cool, but what really the market has to respond to in these sorts of situations is a need for code approval. Helix is an alternate building material, alternate reinforcing material. We have to approach it that way. There are clauses in the building code that allow the use of alternate means and methods. And we have 2 evaluation reports that certify through third-party evaluation and testing that we meet the requirements of the building code with Helix. The first one is the IAPMO ER279. This has been around for about 10 years at this point. That report relies on more traditional reinforced concrete design methods, looking at post-crack performance. The ICC ES 3949 report's been around for 5 years, and that uses that modulus rupture behavior. And we're going to talk a little more about ICC here because ICC it's a group. It's the same organization that actually publishes the International Building Code, International Residential Code, and we've recently released enhancements or an update to this report that has the same bones of the report are there, but we've added some tables to make it easier for our partners to use that report without the need for a lot of engineering calculations. So we'll talk about that. The other aspect I mentioned, the environmental performance, I guess, pain point or motivation for seeking better ways to do things earlier is environmental performance. Now, this is something that you kind of get as a side effect of using Helix. It's not something that maybe you would use Helix specifically to reduce carbon footprint. We have quantified the carbon footprint performance, or the GWP, for Helix in an EPD published by ASTM, which is available. If anybody would like a copy, you can let Peter know and we can get you one. That EPD can be used to develop the global warming potential, or GWP footprint, for the entire project. And groups like the Athena Sustainable Building Materials Institute, has software, online software that can do that. But the other area is the LEED 4.0 framework. We can offer points there. And I know for a fact that is an area where you can actually upsell. So people are willing, believe it or not, people are willing to pay more in rent for a LEED certified facility, a LEED Gold or LEED Platinum or whatever level. They can, a real estate developer can charge more. There are people that will pay more for that. We can provide up to, I think, 8 points in that area, depending on where the project is located, and those points are indicated there. So I talked a little bit about the performance, both sort of from first principles engineering to environmental. How do you get it into the concrete? How do you use it? There's not a lot. I do have a webinar that goes into the very particulars of this, but basically it's pretty simple. The easiest thing to do is just order it from your ready mix producer. Then it comes in the truck and you're good to go. You can order it if you're a contractor and add it at the site. Usually that involves climbing up the ladder and dumping the box in slowly. If the ready mixer is doing it, typically what we ask them to do is put it in first. That tends to give a more or a less error-prone method or more robust method of adding it, because the Helix gets the benefit of the mixer, or the monopoly of the mixer, for at least a few seconds before the rest of the material goes into the truck. You dump it in there with a little bit of the headwater, and at the charging speed, the truck pulls all the Helix out of the bottom of the truck, and then when everything else goes in, it feathers it into the rest of the mix, and you get a really, really nice mixture each time. You add it on site, you got to be a little bit careful to add it more slowly. Once it's in the concrete, you're just going to use your ordinary finishing methods. If you're going to do any kind of polishing or even a broom finish, I would recommend that you do a test area. We have really good results with both, but there are a few best practices that we would provide if you're going to do that, and we always advise the customers really take the time to do a small area, just make sure they're happy with how it finishes. It does pump just like any other concrete, although one of the advantages of using Helix is often you don't have to pump, because you could just direct discharge, because there's no rebar to get around. From an engineering perspective, we do have a full service engineering department that will do engineering in accordance with one of those reports for you on your project. We don't charge for that. We can provide stamps in any state for delegated design, or we can provide just an engineering letter that has the calculations and all the details behind it. We are made in the United States, or manufactured in the United States, made in Michigan. Obviously proud of that. It goes back to our mission statement a little bit in terms of impact to the community. But, if you do have specific requirements for Buy America certified product, we can provide that. Everything is made in Grand Rapids, Michigan. So now we're going to talk a little bit more about this ICC report. I'm not going to get into the weeds too much here, but I am going to talk a little bit about how the report's structured. I don't have any of my offer links. Maybe Peter can put a link up to our website where you can download the ICC report, but you can do it with your phone with this QR code here as well. This will take you the updated ICC report. It was updated June 15th, I believe. And it has some of these new tables in it. Actually, the illustration here is the version from before that, but I'm going to show you some of the newer stuff here. We have different types of design that are covered in here. Some of the new types that weren't there before are the composite metal deck type of design, and then we have these tables and examples that are new, and then we have a New York City supplement for our New York customers. So for the engineers in the room, the method is really basic for how this report works. I showed you those modulus or rupture tables earlier. The table simply uses a linear elastic design method where we assume the concrete is behaving in its uncracked state. We apply a factor of safety, a scale effect or scale adjustment factor, and basically we're multiplying the modulus or rupture times the section modulus and putting some factors of safety on it, and that gets us our bending capacity. If we're looking at shear, we just treat it as plain concrete. Most of these things are governed by moment. And if you compare what you can do using the standard ACI 318 Chapter 14 approach to what we can do with Helix, you can get about twice the capacity. So the factor that we use here, this LF factor, is 5 in ACI 318. We have a table in our report, and you can see we range from using 8 to almost 12. So there's your 2-time improvement. We have quantified behavior in dozens of different mixes and also different size beams. So large beams, small beams. There is a scale effect that occurs as you get deeper than, say, 12 inches. And that's taken into account in this factor here. So basically what you're going to do is you're just going to follow your standard ACI 318 Chapter 14 calculation, but instead of using the 5 here, you're going to use a table value from the evaluation report. So for engineers, that's really simple, but for the rest of us who are trying to maybe work with ready mix or we're contractors, that's not very easy to turn into a real life benefit. So we've done a number of things to make that easier. First of all, we have what's called EER 3949. Now, this was a new product that ICC put out about a year ago. We were the first report holder to hold a report. And what this does is it takes that ESR report, the one that I just showed you, and we use it to calculate designs and provide construction details for residential IRC applications. So this would be above and below grade walls. So like for those of you who are doing ICF or basement wall construction, we have a elevate or a section drawing that shows a typical structure in plan view with these sections. And then in the sections, you can drill into what does that connection detail look like? And then there's a table that shows you, so for this basement wall here, if you have 9-foot backfill and maybe 7-foot or 9-foot wall with 8-foot backfill, and you have an 8-inch wall, you're going to use 13.5 pounds with 4,000 PSI concrete. So it tells you what you need to do to achieve the level of performance that's required by the code. And the neat thing about this report is engineered design is not required, just like with IRC. So a contractor or ready mixer can use this without bringing in an engineer of record on it, provided the project falls within the scope of the IRC. So that's how we handle residential. This EER report covers also footings, above grade walls, and below grade walls. I just showed you one example of a below grade table. There's also an above grade wall table. So if you're doing residential construction or you're a ready mixer, we have a lot of ready mixers who just have this in their office, and they market the product to residential contractors. If you're an architect, you can use this as well. All the calculations in there, if you run any of those calculations, if you're an engineer, you're going to get the result that's in there based on the ICC report. So that's how we handle residential. For commercial, these are kind of the applications that we target, and this is kind of a typical warehouse type building. We do these types of buildings as well as mixed use, but just about any kind of building. This is just an illustration. Outside, we're doing site paving. We're doing precast drainage type structures. We do footings, poured walls, slab on grade, column footings, and composite metal deck and roof deck. So I'm just going to kind of talk a little bit about each of these applications a little bit. The first one that we talked about was the foundation wall. In the evaluation report, we have an example calculation for the engineers, so you can actually replicate the calculation in ICC. This is kind of a typical example of kind of what you would need or what you would do for a particular situation. So for example, in this instance, you might be able to replace number 4s at 10 inches with 9 pounds per yard of helix. So just kind of an example, or go from a 10-inch wall to an 8-inch wall. So just some examples of value. Most people are seeing either a reduction in rebar or a reduction in the ability to or a reduction in the amount of concrete that's needed for a particular application. These are some pictures of walls. This is an ICF structure in St. Martin, and this is a typical residential application, residential poured wall application. Square column footings are another great application for the product. We have many customers that are using it, really as a standard in square column footings. And in the ICC report, there's actually a table now that allows you to go on the notes page. If you go on the notes page and you get the soil bearing pressure and you look at the size of the original footing, you can determine the thickness required for a helix footing. So obviously it very much simplifies the process of pouring these things if you don't have to put rebar. It just becomes a dig and pour. You can actually even reduce the thickness of these if you use some type of stay-in-place form around these things. I think it's a 2-inch increased thickness that's required for soil-formed structures that's included in those thicknesses. So that table's good for really any interior square column footing. If it's a combined footing or something's going on, it's a different shape, you would have to come to us for engineering. Otherwise, it's right in that table. The South Point Business Park, VP 163 in Virginia is an example. This is a Hollingsworth project where helix was used in both the footings and the slab on grade. And I should mention that's currently in use by Walmart. Another example of footings is Gemini or Prime Energy. This is solar foundations in Nevada. And the great application because such a remote location, like you can see here, trying to get rebar out to this solar site in the Nevada desert is challenging. But we were able to eliminate all the rebar in favor of just a single dowel basket, saw cut joint. down the center and Helix throughout the rest. So improves logistics and, you know, performance as well in that very extreme kind of heat and cold environment. So once again, in wall footings, or no, this is the square column footing example. These are just some examples of things that we can do. If you approach things using just a conventional rebar, typically you're going to have number 6 bars in these footings, and we typically can eliminate that at the same thickness with 13.5 pounds per cubic yard of Helix. If you're going to try to do that with plain concrete, you'd have to use 25 inches. So, you know, obviously kind of a no-brainer there, you know, and that's one of the reasons a lot of people don't use just plain concrete. The thicknesses just have to be too much. Wall footings, almost exactly the same application, but instead of kind of a 2-dimensional, it's a 1-dimensional strip footing. Same type of table. Look at the page 1 of your drawings, of your notes. Look up the soil bearing pressure. Look at the original width of the footing, and this will tell you the depth of the footing required with Helix. So this is an example of a building that was done for a sound stage in, I believe it was overseas someplace. So that's an example there, or this is a little bit of another example. If you had number 4s at 10 in a 10-inch thick footing, you would be going to a 10-inch thick with 13.5 pounds per cubic yard of Helix. Example, Wilson Crossing. This is a mixed-use facility in Michigan where we eliminated the rebar and all the strip footings. We did leave some bar. You can see they have some bar. We did leave some bar in the corners. Not absolutely necessary, but the contractor just wanted to make sure that there was some additional bar there to deal with dimensional change as those things cured. The next one is composite metal deck, and this is actually, I took this picture. It's at the LaGuardia Airport in New York. But you know, you've got these metal pan deck with these shear studs, and typically what's required is at least a layer of light mesh. We've gone and actually done testing of actual composite decks with Helix in it to demonstrate that using these dosages of Helix provides the same level of crack resistance, or better actually level of crack resistance than the original rebar that's required. And that is in this table and in what we call the type C design method in the ICC report. So we can typically go in and replace that wire mesh or rebar that's in there for temperature shrinkage at 6.7 to 9 pounds per cubic yard. And then, you know, one kind of fun example for us here in Michigan is what's called the Hudson site. This was a site where there was one of these iconic, actually, my grandmother-in-law worked at the Hudson's department store that was torn down on this site. And now they're building a 900,000 square foot building that has metal deck on it, where Helix is on every floor in this building on composite metal deck at 9 pounds per yard. So really kind of a high profile project for kind of the redevelopment of a lot of the parts of downtown Detroit. And then of course, we go to the more, I guess, typical or mundane application of slab on grade. We have tables, not in the report, but in our application guide and our website, that allow you to look at, okay, you know, if I'm going to have racking in this warehouse, or I'm going to have certain forklift axle loads, you know, here's how thick my slab needs to be, and here's the load bearing capacity based on the dosage. So we have these tools in place to make it easy for engineering. We can do the calculations, but you know, I say this is mundane, but our sales team definitely likes these types of applications because there's usually a lot of concrete in these things relative to a square column footing or some of the other applications. And just a couple cases in point on that. We have the Ultium Cells manufacturing facility. We have done all 3 of those so far with General Motors with great success. This one was the first one. It was a partnership with Ultium Cells. Gresham Smith is the engineer of record, and Barton Mallow as the concrete contractor. We've now worked with Barton Mallow and different engineers on the 2 subsequent projects for Ultium Cells, and we're looking at the 4th one as well. We do all kinds of things on these. Some of it is just basic slab on grade. Some of it is footings. Some of it is foundations for equipment, mezzanine slabs, you name it, we've been in it. So really great opportunity for us to partner with some local companies to kind of make this happen. So we're very excited about that. I'm still looking for those first Silverados to come off the line of this plant. I haven't seen it yet, but I think they're getting closer to actually, starting to produce some of these Ultium Cells vehicles. Another one is the Graco project, and this is in Minnesota. This is using what we call our Infinity slab, which is an extended joint system. This had 50 by 50 foot joint spacing. A little bit higher dosage of the product because of the joint spacing. Very high racking capacity. This company makes a lot of different types of tools at this facility. And then, another application, of course, is pavements. Pavements is something that, there's a lot of use, particularly in southern states where it's just too hot now to use asphalt. We've actually evaluated a product under 5 million load cycles. This is an easel loading tester where we had a control pavement that was just plain concrete, and it was compared to Helix, and we were able to show a reduced thickness of the Helix pavement, perform better than the full thickness of the plain concrete pavement after 5 million load cycles. We have tables in the report that use the ACI 330 methodology along with the modulus of rupture values in our report to provide prescriptive design for parking lots and site paving. And this is the one for commercial. There's one for industrial as well. But the methodology can also be used with, say, the AASHTO design approach. It's all based on modulus of rupture. This is just kind of an example of how that works. If you scan this code, it'll take you to pavementdesigner.org, which does all of these types of pavement designs automatically. And what you're going to do is you're going to take that ICC report and you're going to put the modulus of rupture that you calculate in that right into this field here, instead of what it uses as the default, and then calculate your thicknesses based on that. And what you'll typically get is, a 1/2 inch to, in some cases, 1.5 inches to 2 inches reduced thickness when you use Helix. This is an example of a project down in Texas, in Laredo. This is all Helix site paving. This is for Park Avenue Construction, Allied Properties. A big parking lot, lots of vehicle traffic on it. Not going to let me out of it. Hold on. I think it maybe took me out of the. Here, let's do this. And just continue to kind of go through applications. The other application is in tunneling, and we won't talk a lot about this, but we have been used in major civil infrastructure type projects. And one of them is the East Side Access Tunnel in New York City. So all that said, we've covered a lot of stuff today. What I hope I'm able to convey to you here is that, this is a product that's been around for 2 decades. It has the technical backing and the experience to be able to be used in any of these applications that I highlighted. if you got a project where you would like to kind of consider this, you can go onto our website. I don't have the button today, but you can just go to www.helixsteel.com and go to the specification tool in there. And all these evaluation reports, as well as application guides that kind of walk you through, say, an insulated concrete form construction project, typical drawing details, things like that are all in there. All the things that you would need to investigate the use of the product for your application. You can do that purely on a self-service basis with this specification tool. It's under Resources Specification Tool. If you have a more specific project in mind, I would encourage you to either use the Contact Us or Submit a Project tab. The Contact Us will just take you to a form that will email our sales team. The Submit a Project actually has a place that allows you to actually input a drawing and has a few more targeted questions about your application. What will happen if you do that is within 2 business days, you'll get back some information from our sales team. And we're not, it may or may not work out at that point, but what you'll get back is first an answer to the question of yes or no. Can we approach the application you're asking about with Helix? And if the answer is yes, it'll be, here's about what it would take to do that. And then our sales team will also get you pricing, and then you can make your own judgment as to whether you see value in the application. I will say that a lot of times time is a critical factor as well. And that's a little harder to put on a spreadsheet. So when the salesperson reaches back out to you, they'll walk you through that. And if you guys decide that, yes, this makes sense for me and the end user, then, we'll take another step and provide a submittal package for you that will satisfy the engineer's needs and the building official's needs. And if not, that's okay too. At least we've looked at it and we've tried. So a lot of great resources on the website, www.helixsteel.com. And then, just kind of wrapping up, some contact information there. We work with, it doesn't matter where you're coming at it. We have contractors, builders, engineers, developers, other professionals that are really looking to make their projects better. And, the other thing, and I hope I've conveyed it in this without, coming across too much, just, with a tagline, but this is something you can pursue with confidence. It's something that we've been doing for 20 years, 2 decades, with very, very good success in the market across a wide range of applications. It's made in the United States. It's backed by great people and great engineering. And, we would love to be kind of a part of your next project. So this is how you can reach me. You can reach out to me on LinkedIn or email me if you have questions. I'm going to kind of open up my chat window now. We did pretty good here. We're at 45 minutes. Let's see were there any questions here that can you eliminate the steel that we typically place around door openings in a concrete wall? Good question, Jesse. The answer to that is no. If you read the EER report or either of the reports, it's going to tell you, it's going to direct you for residential. I believe put a number 4 bar around those openings, and for commercial, it's a number 5, I believe. So that's, I could go into a little bit more discussion about it. Obviously, we're aiming to replace kind of that field steel in those applications, and that's an area where you're going to have like some concentrated stresses as well as some reentrant corners because of the geometry where you can get shrinkage, and having that rebar there just gives you that added protection in those areas. But good question. All right, well, then we'll just kind of wrap things up here. I'll hang around for maybe a couple more minutes in case anybody thinks of another question. Denise, thank you. But you've used it in a lot of your foundation footings. One of the applications that's now in the EER report, which should make it even easier to implement. All right. Well, I'd love to have, thank you for spending your Friday afternoon with me. Have a great weekend, everybody. Thank you for your business. Those of you who are existing customers, we would love to earn your business for those of you who are new. And Richard is one of our great long-standing clients. So, thank you for that. We'll look forward to seeing you next time. Have a great weekend, everyone.